So you attempted page 44 and page 45. This is the last things of this lesson today. Well, not attempted, you've hopefully finished. And it's so important that you don't just cop out and follow the videos and copy the answers down. Remember, if you want to actually learn, you've got to put some effort in. You've got to do some thinking. That requires you to get stuck in yourself, get stuck occasionally. This idea, this hypercorrection effect, is your brain learns more if you attempt something first, even if you get it wrong. So when I go through the answers soon, if you've attempted it, you've done so much better. And it may be that you just watch part of these answers and say, oh, that's how I do it, and then go through and finish them. So what I've got is I've actually just got quick answers. So on page 44, question D and E, which are the same. Remember, one's a graph using the graph to answer, and one's using the equation to answer, so you should get the same thing. It's 0 meters per second. F and G, you can check your answer. Displacement was 170 meters, and the same for question 3, page 45. These are the answers. Acceleration is minus 2.5 meters a second, and the distance is 135 meters. You don't need to watch the rest of the video. If you've got those, you must have got the ones before that right. But if you want to go through and see all the answers, I'll go through them now. Right, a dune buggy travels 20 seconds at a speed of 8.5 meters a second. It doesn't seem to be changing its speed. It just travels at the same speed. So this seems like it's oh, I'm not doing that. A constant speed situation. So make a well-labeled diagram. Not my motion map, just a well-labeled diagram. And they seem to be going the same speed. V equals 8.5 meters a second, and V equals 8.5 meters a second. My motion map is there because it's there to just get an understanding and to really get these positives and negatives in the right direction. Velocity doesn't change. Position time graph. Wow, our velocity is not changing. We're going at a steady speed, so it's a straight line. Our velocity is not changing, so we can go like this. I can put some numbers on these as well. It's 8.5. That is, and it goes for 20 seconds. Right, use your graphs to find the average acceleration of the car. So if I go back a couple of pages, if I want to find acceleration from a velocity time graph, I can use the gradient of the velocity time graph. The gradient is rise over run. How much does this rise by? Well, it doesn't rise at all. It's horizontal. 0 meters a second it rises by, and the run is 20 seconds, and that equals 0. So acceleration of the car while at steady speed, 0 meters a second. Using a formula to do the same thing, to check your answer for D above. If I go back to this page 43, the formula, it's a constant speed. Well, it doesn't really tell the acceleration, does it? Let's use this first one here. I'll write it down for you. Vf equals Vi plus At. I want to work out A, so I'm going to minus Vi from both sides. I get Vf minus Vi equals At. Now I want to divide by T, get Vf minus Vi over T equals A. Put the numbers in. Vf final velocity is 8.5 meters a second minus initial velocity, it doesn't change, 8.5 meters a second times 20 seconds. What's 8.5 minus 8.5? 0. 0 divided by 20 is 0. Same answer, on track, great. Use the graphs to find out how far the car travels in this time. So I'm going to use my velocity time graph to work out how far it travels, because I'm going to go back to this page again. My velocity time graph, if I work out the area under that velocity time graph, it tells me the distance. So the area under here, it's a rectangle, so that's base times height. So area equals base times height equals base was 20 seconds times height was 8.5 meters a second. That is 170 meters. Using a formula, find how far the car travels in this time. I can go back to my formulas. I could use any one of these, knowing that acceleration is 0 would make life easy. Now let's write this down, but also let's write this down. I'll show you that they're actually the same for this situation. The constant speed formula, and the acceleration formula, but knowing acceleration equals 0. So that was d equals vit plus half at squared, and this one was distance is velocity times time. If I work this one out, I have velocity 8.5 meters a second times my time of 20 seconds equals 170 meters. Great, same answer as here. If I was to use this formula, I can use this formula in this case because I know acceleration is 0. This is acceleration is 0. So 0 times a half times t squared is 0. If I get rid of that, I just have distance equals initial velocity times time. That is the same as that. So I'll get the same answer. Page 45. At t equals 0, so time equals 0, a car has a speed of 30 meters a second. It's going along really fast. After 6 seconds, it speeds down to 15 meters a second. So that's after 6 seconds. Initial speed is 30 meters a second. Final speed is 15 meters per second. All right, make a well-labeled motion map. This is really important. Don't skip this step because it helps you out figuring out the positives and the negatives. It's going fast at the start. By the end, it's going slow. So the velocities are getting smaller. This means if this is my 0 and this is my positive, my accelerations are in the other direction. It means my accelerations are negative. Negative, that's how I write negative, with a minus sign VE. Something to remember, or something to be useful for the rest of it. Draw a position time graph and a velocity time graph for this situation. So it's going away, it's going fast to start with, so it's steep, and then it slows down, but it doesn't completely stop. Its velocity starts off quite fast. Go away. And after 6 seconds, 1, 2, 3, 4, 5, 6, its velocity started off at 30. Its velocity is down to 15 at this point here. It's meant to be a straight line. Use your graphs to find the average acceleration of the car. So I'm not going to go back again and show you from page 41. You almost got this off by heart now. For a velocity time graph, the acceleration is the gradient, the rise over run. So in this case, it starts at 30, and my rise over run is it goes down to 15. So my rise is minus 15 meters a second, and my run is 6 seconds. I work that out, and I get 2.5 negative meters a second. It's this one here. Use a formula. I'm going to use the same formula I've always used. I'm going to rearrange it really fast because you've done it a number of times, and you should practice doing this if you can't do it. But it was A equals VF minus VI over T. Put in my numbers. My final velocity was 15, minus my initial velocity was 30. My time was 6. 15 minus 30 is minus 15 over 6 is 2.5 negative. That's the same as that. Great. Cool bananas. How far does a car travel in this time? Same deal. Area under the graph. This is a bit harder though, area under this graph, because it's made up of a triangle and a rectangle. when you got to do this, you got to have a triangle and a rectangle. So my triangle is half base height. And my triangle is half times the base is 6 seconds times the height. From memory is 15. And that's 45 meters. The rectangle, this bit here, base times height is 15 times 6, which is 90 meters. Add those together, I get 135 meters. All right, using a formula, I've got my initial velocity 30 meters a second. I've got my final velocity 15 meters a second. I've got my acceleration negative 2.5 meters per second. Got my time equals 6, and I write out displacement is the thing I want to know. There's a number of formulas you can use. I'm going to use this one here. Excuse me. VIT plus half AT squared. Put my numbers in. Initial velocity is 30 meters a second times time is 6 seconds. So that's that. Plus half times A is negative. That's really important. Negative 2.5 meters a second times time is 6 squared. 30 times 6 is 180 meters. Plus half times 6 squared. That's 36 times half is 18 times 2.5 is negative 45. 180 plus negative 45 is 135 meters. You would not have got that right if you did not have the negative. Okay, and some people will miss out the negative, but if you've done, and just to check these are both the same, yes. If you've done your motion map to start with, this is why I stress it, you already knew that your acceleration was negative and you weren't going to make that mistake. Cool. See you for the next lesson tomorrow.